All right, guys. So we are, for the most part, done with a eighth grade curriculum. Okay, meaning we've kind of covered everything we need to cover up until now, in preparation for the STAAR test. Now that STAAR test is scheduled for May the 11th. Okay, so that's going to be kind of my first note here for you, because they're only going to have a very small window for us to actually complete this. Okay, all tests must be done in person. They will be done online, but they'll be done here on campus. They must be monitored. Okay, and the school will be reaching out to you with regards to that with more specifics as we get near. Okay, but what we're going to do for the next 6 to 7 weeks is basically we're going to review the year at a glance, a little bit at a time, with more focus on certain things as we prepare for that test, so that we can all kind of get a feel for it and show our mastery on that day. Okay, so that's tentatively the day we're looking at. All right. So in unit 1, okay, it's a very quick, short review of unit 1. What was it? Well, we talked about the real number system. Okay, that was unit 1, was the real number system. Okay, and that had a lot of layers to it. But what we need to remember is basically we spent some time doing two different things. We either classified the number or we evaluate. Okay, so those are the two things we're going to cover in this review. You're either going to classify it or you're going to evaluate it. Okay, and we'll get a little bit more specific with evaluating and classifying as we see different types of numbers. Okay, but let's kind of look at first evaluating. Okay, because that's for the most part what we're used to doing. Okay, so evaluate. Okay, and I would define it, but we should know what that means, right? So for the most part, we're going to take an expression and we're going to condense it to its smallest form. And so we could take something like, example, okay, we'll say 4 to the third minus 3 times absolute value of 7. Whoops, that's another. And then we'll say plus 18. I don't know how that's going to work out for us, but right, this is how we have to work. All right, so this is a absolute value symbol. All right, so that's the first part that might throw us off. We have two vertical bars like that. That just means absolute value. But regardless of what's in the expression, what we need to remember is that we are following Pemdas. Now, if you're not familiar with Pemdas, that's unfortunate, but we have parentheses, exponents, and then this is where a lot of problems come in, because it's not multiplication then division. It's actually multiply or divide, depending on which one comes first, right? So if division actually happens first, then you would divide first. If multiplying happens, then you would multiply first. And then the same thing is for add or subtract, right? So it really depends on which one happens first. So in this problem, okay, you can see that obviously we have some exponents and things to deal with. So we'll do that first, but we have a minus here and an addition here. Well, the subtraction comes before the addition. So whatever needs to happen first. Okay. We can't add this 18 to whatever this number is before we do this subtraction. Okay. So we have to follow those rules. So we look for any parentheses. Well, these guys, these absolute values, they actually kind of work like parentheses. We need to get that number out of those first. They're like grouping symbols. So the first thing I would do to condense this, and I'm just going to rewrite it, 4/3 minus 3 times the absolute value of -7 plus 18. Okay, so the first thing I'm going to do is take that out of absolute value notation. All right, so it's 3 times the absolute value of 7. Now, the easy part of that is absolute value is just a distance from 0. Okay, so whatever number you have in there, you're basically just going to be talking about the distance of that number from 0. So, for example, let's say -7, right? The distance of -7 from 0 is 7. The absolute value of 7 is 7. Okay, because the distance from 0 for each of those numbers is 7. It doesn't matter if it's negative or positive. It's always going to have a certain distance. Well, distance is always a positive value. It doesn't matter which way you travel. So we're going to take that out and call it 7. Okay, and then plus 18. All right, so we've done the parentheses or grouping symbol that came first. Now we're going to move to any exponents. Well, we have an exponent here. That's 4 to the 3rd power. And again, remember, that's not 4 times 3. All right, we can't do it that way. That is 4 times 4 times 4. So I need to think about, right, what is that? Now we have calculators, and I'm going to go through and type this all into a calculator for you, just to show you how it works. But 4 times 4 is 16, times 4 again is 64. So I've got 64 minus 3 times 7 plus 18. Okay, so I'm just taking care of one little thing at a time in each step that we have. The next thing, of course, I've taken care of exponents. Now it's multiplying or dividing, whichever one comes first, left to right. I see multiplication, and then there's nothing else. So we're going to do that multiplication. So 64 minus 3 times 7 is 21. So there we have it, 64 minus 21 plus 18. And it's very important that, right, I do this in the order that it goes, right? I don't want to subtract this 39, right? 64 minus 39 is different than 64 minus 21 and then adding 18 back to it. Okay, that's where the mistake generally happens. All right, so now we have 64 minus 21. So that's 43 plus 18. And so I get 61 as my final answer. Okay, versus doing it the other way, right? If I would have added first, I would have gotten 64 minus 39, which is a totally different answer, and incorrect. Okay, so order of operations is how we're going to evaluate these numbers, and each one, right? So this is just all of this, okay? All of this right here was a real fancy way to write the number 61, okay? So if you think about it that way, right, I've just put 61 into, right, this big puzzle, but really it's just 61. This is just a big fancy way to write 61. Well, we have calculators, guys, so we don't really have to work so hard. We just have to know how to enter these things into calculators, okay? So if I was going to enter this problem into a calculator, I'm going to jump over to Desmos, since that's our online version. And right, all I've got to do is type this in exactly how it was. It was 4 to the 3rd power. So 4, I'm going to use this little a to the b right here that allows me to put the 3 up there. I'm going to move down or over, right, so that I'm next to it. And I'm going to subtract, right, 3 and then times, and then we even have an absolute value symbol here. All right, so of -7, and we'll close it. Okay, and then plus 18. Okay, and there you have it, right? Didn't need to do anything. All I needed to do was type it in there exactly how it's written. Okay, so our calculator does all of that for us. Easy enough. Okay, so if you're still working on that quiz, then definitely go back and double check those responses. In order to enter a fraction, right, go ahead and put 9 divided by 6, and then go back and edit your numerator to whatever it needs to be. I know this one is number 4 was 36 divided by 2 times 6 plus the absolute value of 4, right? So again, the division is happening first. That's a -4, I'm sorry, but it doesn't matter. It's the same. And then it was all over, and that was 18 minus 32 divided by 4 to the second power. Okay. So you can see this is still grouped together. That's got to be so that should be 32, that should be 12, that's 16. And then we have 36 divided by that times that. So this needs to move out. So we gotta fix this because our calculator got a little out of order here. Those 36 divided by 2 times 6, and then plus the absolute value of -4. That's going to be a little easier for us there. And then the other one's okay. I can write it that way. Yes. Okay, so that should be your answer there. And we can turn it into a fraction as needed, 7/16 or 0.4375. I believe I said round it to the nearest hundred. So hopefully you got 0.44 on that one. All right, so next thing we need to talk about is classifying, okay? When we classify numbers, it must fit into one of the categories. Now, the typical way we're gonna draw this up would be using circles or boxes, okay? And so we have this giant box, okay? And for what we know right now, it is divided into 2 main sections, right? So this entire box is what we would call the real number system, okay? That's the whole box. Now, within that is 2 little subcategories, okay? So you have irrational and rational. Okay, and it's been a long time since we talked about these, but those are the 2 subcategories of the real number system. Because we need a real number system because there is such thing as a unreal, or what we would call an imaginary system. Okay, but right, besides the point. All right, so rational and irrational, right? So what does it mean to be irrational? Okay, not like I don't see anybody's opinion, and I don't accept facts for arguments, and I'm illogical. It is a type of number, right? Irrational. And basically it cannot be written as A over B, right? It cannot be written as a fraction A over B. So for example, the best one for us that we're most familiar with is pi, okay? You have no way of writing pi as a rational number or as a fraction because right? It doesn't have an end. There's no way to find where it actually stops at, okay? The other example is very important. Any imperfect root, okay? And what do I mean by imperfect? All right, so we're talking about things like square root of 3, square root of 5, square root of 51, right? These are all numbers that don't have perfect squares, right? Whereas if you think about what is a perfect square, right? We have something like the square root of 16, right? That is 4. Okay, so that one has a rational root. Okay, so what does it mean to be rational? Well, it's just the opposite, right? So to be rational, it can be written as A over B. All right, so we can write it as a fraction. All right, so obviously fractions are rational numbers, but so is whole numbers, right? 0, 7, -7, square root of 49, which is 7. Okay, even things like 1/3. Well, 1/3 is a fraction, but remember, right, from our benchmark days, that is a repeating decimal. Okay, repeating decimals are completely fine as fractions, right? Because we know 3 repeating is a third, right? That's got to be okay, right? That somehow there's a way to transfer a repeating decimal into a fraction form, and there is. It's kind of a complicated algebraic approach using systems of equations, and I don't want to go there right now, so there's no use in knowing that just yet. All right. Now, within the rational system, okay, there are subcategories, right? So our subcategories are as follows, right? So you have the rational number system, and things would fit inside of that. And that is going to be integers. Okay. So inside of rational, you have what are known as integers. And this is all whole values and their opposites. Okay, so positives and negatives. That's what an integer is. Okay, so it's all whole values and their opposites. Basically, your positives and negatives, but they must be whole values. Okay, no partials allowed, right? All have to be whole values. Okay, and then within integers, okay, going back up, we have another subcategory here, and that is going to be our whole numbers. Okay, so you have whole number system, which is 0 and whole numbers going up. So 0, 1, 2, 3, 4, etc. Right? Those are our whole values. That's our whole category. In order to make it into a whole category, you need not only to be a whole value, but you must be also positive, right? So 0, 1, 2, 3, 4. Okay, and so continuing. Okay, and then the last one, okay, depends on who you ask as to which you're going to call it. Typically, it's called your natural numbers, okay, but it's also called our counting numbers. So natural, that's going to be our last one. This is just your counting numbers, no zero. Okay, so starts at 1, 2, 3, 4, and up. Okay, so no zero in the natural number system, but it's all your counting numbers going up. Okay, so it's going all the way as far as you want to count up. Those are natural numbers, so also called counting numbers at times. All right, so as long as it's classified as one of those, okay, I could put it into a category. Now, which category it goes into really depends on its best placement. Okay, so for example, let's take negative 18 over 6. All right, so negative 18 over 6. It really depends on, okay, does this belong in the rational category? Well, yes, it's a fraction, okay? But the question becomes, what is this actually hiding, right? Is it hiding something else, right? Negative 18 over 6. Well, 18 divided by 6 is 3, so that is actually negative 3. So where does negative 3 belong, right? Is it a rational number? Well, yes, obviously negative 3 can be written as a fraction many different ways. But it's best to be classified as an integer. Okay, so we always want to figure out what is the best way that I can write this. Okay, but it doesn't belong in the whole category because it's not positive, right? So the best it can be is an integer. All right, so we want to look at everything for its final value and then its best placement when we're classifying. All right, so one more thing to talk about real quick in Unit 1 that we covered, and that was scientific notation. Okay, and the reason I want to cover it is it's really simple. This is scientific notation when you have something like this. Right? So 4.7 times 10 to the negative 7, right? You just have to know the parts, okay? So you have your decimal here. It's all focused on the decimal, okay? The decimal is where we're going to start working from. And then this, right, tells us which way, this, how many. Okay, so start here, which way, how many? Okay, that's all scientific notation is. It's a way to express very large or very small numbers in a more condensed fashion, depending on the number. But right, we can simplify it. We can get the final result, right? You might not know what this number is. Is this, right? What classification is this? And some people might say, oh, well, it's a rational. Because right, we have 4.7, that's 4 7/10, that's a fraction. So we can put it in rational numbers, which is true. It's definitely a rational number, but what kind of rational number, right? Because depending on which way we move that decimal, it might actually be a whole value. So you have to be very careful. All right. So example here. So we'll do 4.3 times 10 to the 4th. All right. Just to keep things simple. Right. So is this a rational number? Yes. Right. It's definitely a rational number. But what is it? So you take that 4.3. This is a positive 4. So I'm going to be moving right. All right. So positive exponent, move right. Negative exponent, move left. Okay, so I'm going to be moving right 4 spaces. So 1, 2, 3, 4. Okay, so all we do with these empty spaces is plug in zeros. So this is actually 43,000. Okay, so 4.3 times 10 to the 4th is actually 43,000 in disguise, which would actually make that a natural number. Okay, so we got to be careful with scientific notation, right? we got to actually do it to see where it falls. Okay. And then one more, just to kind of go the other way with it. So let's say we have a very small number. All right. So that is tenths, hundreds, thousands, 10,000, 100,000s, millions, 10 millions, 100 millions. So that's 8,700 millionths. And we want to change that back into scientific notation because we don't want to repeat this every time. Okay, so the first thing you want to do is you got to recognize that we want that decimal right there. There always needs to be one number in front of the decimal and then whatever behind it, right? So this is going to be 8.7, and then times, it's always 10. And then how many times did we move it? 1, 2, 3, 4, 5, 6, 7. We moved it 7 times. Okay, so there we have, right, -7 or -7. So that is the final product to say that is that number written in scientific notation. Okay, so just really quick on scientific notation, nothing real fancy, but wanted to cover it again just because it is an easy concept once you get it, but we need to be able to recognize it for what it is. Okay, any questions, comments, or concerns? Definitely hit me with a message. If not, we'll be going over that quiz and then pushing forward into that next unit. So we'll be looking at equations. All right, thanks, guys.